So the first definition is the definition of closed set. So already we have learned open set. What is an open set? If you consider a metric space M, and if you take any set A from metric space, and if you consider a point say X from A, then when is the set A from the metric space is called an open set. If you construct an open ball with center X and radius R, then and that open ball should be contained in A, then A is called an open set. So what is a closed set? Closed set is an opposite to open set. So closed sets or sets if the complement of the set is open. Suppose if you consider A, if you have to say A is an open set, then you should say that A complement is an A is a closed set, then you should say A complement should be open. So just for example, I'm taking a closed set A comma B. So this is obviously a closed set. So how will you prove that it is a closed set according to the definition? So you have to say the complement should be open. That is to prove the complement is open. So what is the complement A B complement that is equal to? I can write like this, infinity, because in OR, okay, in OR closed A comma B is a closed set. So in OR the real line is consists of minus infinity to plus infinity all the numbers. Therefore minus infinity comma A union B comma infinity. Since you don't want this A and B, because the complement should be just like this, okay. So we know it is very obvious that minus infinity comma A and B comma infinity are open set. Therefore if this and this are open set, then we can say minus infinity comma A union B comma infinity or open set, is an open set, hence it is in closed set. Okay, so the next definition is something that you have to understand by the concept. The definition is limit point. So when it comes to limit point, do not confuse it with interior point, that is int A. So what is interior point? If you take a metric space M, and if you consider a subspace A from M, and if you take a point X belongs to A, then when will you call this X as an interior point? If you construct an open ball with center X and radius R, then this open ball should be contained in A, then this A is called open set and this X is called interior point. Okay, so this is interior point. This is a separate definition. Do not confuse it with limit point. What is limit point? If you take a metric space M, and if you consider a subspace A from metric space M, and if you take a point obviously X from A, and when you call this X as a limit point of A, so the definition is quite big. It seems to be big, but it is very easy. If you construct an open ball with center X and radius R, and if you take from this A, okay, if you construct an open ball B of X comma R, in the open ball one of the points will be R, X, right? If you construct an open ball with center X and radius R, and in your metric space, okay, in your subspace A, if you construct an open ball with center X and radius R, obviously X will be one of the points. But when will you say this X is a limit point means, if you say the open ball of X comma intersection A minus X should not be a null set. What does that mean? A minus X, what does that mean? From this metric space A, without considering the point X, you should have some point in your open ball with center X and radius or other than X. Then this X can be called as a limit point of my metric space A, metric space or my subspace A, right? Okay, we have learned a closed set, right? What is closed set? If the complement of the set is open, then that set can be called as a closed set. So continuing this closed set, there is one more definition. That is closure. What is closure of a set? So that is denoted as a closure, just something like this. Closure, the word itself has its meaning. Closure is set of all closed set in your metric space. Suppose if you have a set in your closed set in your metric space, then a closure can be defined as a intersection of all the closed sets. Okay, intersection of all the closed sets that is present in A. So that is called as A closure. Also we can say, since it is an intersection of closed set, A closure contains my closed set. That is, A closure contains A. So one more definition is that is dense sets. So dense sets, what are dense sets? Dense sets are set that contain all the intersection of your closed sets. So what is the intersection of closed sets? That is, A closure is the intersection of all the closed sets that is contained in metric space. So here your dense sets or sets when the metric space itself contains all the closure. So metric space is equal to A closure, then we can say the set of M as dense set. So obviously any metric space M is dense, isn't it? How? Any metric space M is dense, since M will be always equal to M closure. So set of all closed sets will be present in that metric space. So you can say any metric space, trivially metric space is a dense set. Okay, so this is one of the important questions that you will be asked in your examinations.